Alright, 1.4 trigonometric functions of any angle. Second part, let's look at reference angles a little bit more. It's very important that you get a good understanding of that, so let's draw a couple pictures. I think that will help avoid making sign mistakes when you do problems. So let's see where 130 degrees would be first. Okay, which, let me change colors, so 130 degrees. 90 is here, right? So 130, so in my mind I'm doing 130 minus 90, so that's 40 degrees, so I need to go a little bit, almost to halfway there. So 130 degrees would look a lot like that. Now the reference angle is the angle between the x-axis and the rotation, the terminal side. So if this was 40, so if this little part here was 40, and I'm writing that small so you can't really see it, then that means that there is 50 degrees left here. And that's the reference angle. So the reference angle is the 50-degree angle. Okay, let's do a couple more of those. We'll talk a little less. So 290, right? So in my mind I'm thinking, well, 90, 180, 90, 180, 270 would be here. Oh, needs to be in this form. So 270 would be here. So I got 20 degrees more to go. So if I have 20 degrees here, then I have 70 degrees there. So that is your reference angle. Negative 305. Alright, so negative 305. So in the negative direction, then this would be negative 90, negative 180, negative 270. Right? And then I need to go 35 more this way. So 35 is not to halfway. So that's good. So if this is 35, then 90 minus 35, which would be 55, and the reference angle here is 55. Notice the reference angle is always positive. And the last one, 415. Well, let's do 415 minus 360. So that is 55 degrees again. So that's the same picture, right? So that means these last two angles were coterminal. Keep in mind some of the vocab that we've done. So negative 305 and 415 are coterminal angles because they end up at the same spot. Okay, so other things you need to know. You should be able to find the other values of trigonometric functions based on a given one. So if I told you that the cosine of theta is a half and that it is in quadrant 4, you should be able to draw a picture for that. Now keep in mind that the cosine, if that's a half, then this is the adjacent side, and then this is the hypotenuse. And we're in quadrant 4. So this is 1 and the hypotenuse is 2. Well, then that's actually a special triangle, right? And we know that this is the square root of 3. Actually, this is important. That's a negative square root of 3 because the angle goes down, or the y value goes down. So what do we want? It said the sine of the angle. So the sine of this angle is opposite a negative square root of 3 over the hypotenuse. And the tangent of the angle is opposite divided by adjacent, so we can just leave that. Here actually you know what the angle is. Since that is a special triangle, you should know that this is, well, the reference angle is 60, but that means that maybe given negative 60 or maybe 300 degrees, coterminal again. Usually you don't have to find the angle, just previewing a little bit. Find the values of the sine and the cosine of the tangent is 4 and in quadrant 3. So the tangent of the angle is opposite over adjacent, right? And that would be 4 over 1. So the opposite side is 4, but it's a negative 4. And then adjacent is a negative 1. So it looks like this. So the sine of the angle would be, well, that would be opposite over the hypotenuse, and I don't have that yet. So the hypotenuse here would be, let's call that c, right? So c squared would be a negative 4 squared plus a negative 1 squared, 16 plus 1, so c is the square root of 17. This one's always positive. So there's your sine, and then the cosine is a negative 1 over the square root of 17. And then the last one, find the value of the cosine and the tangent if the sine of theta is 3 over 5 and in quadrant 2. So the sine is opposite over hypotenuse, right? So there's your 3. The hypotenuse is 5, so that's 3 and the hypotenuse is 5, and that's a special triangle. So, but then again, that's a negative 4, so don't forget the negatives. So the cosine of that angle would be a negative 4 over 5, and the tangent of that angle would be 3 divided by a negative 4, which could be written this way as well. Alright, that's it. Thank you.